All right, yeah. So if I'm the programmer in 1991 and I'm writing code where something funny might happen, like divide by 0, what do I do? What happens if someone in the future is using my code and they try to divide by 0? Should the program stop? Should we ignore it? Should we just try again? I don't know. All I know is that something funny happened. What to do when you call the code I wrote in 1991, all I can do is just let you know something funny happened. And then you, finding out that something funny happened, something exceptional happened, you can deal with it the way you want to deal with it. Because I don't know what you want to do when you're using my code if something went wrong. All I can do is let you know something went wrong. So, yeah, there we go. This here is what the programmer in 1991 does. If something funny happens, they raise the exception. Other programming languages, other similar languages call this throwing an exception. Same idea. When this happens, the function stops running. And it doesn't carry on, it doesn't get to its return, no. The function kind of returns the exception instead, not the value. But it's not really returning the exception, but you can think of it like that. This is what a programmer using that code that might raise an exception is going to do. They're going to put a try block, being aware that something funny might happen. I'm going to try something. And that code in there might raise an exception. If it doesn't, it executes normally. And if no exception was raised, all of this is skipped. This is like an if statement for if the code sees an exception. If something in that try block raised an exception, this is like an if statement that says, okay, if you see an exception, here's what you do. We definitely did this last time. Yeah. All right, well, I'm going to skip it then because we already did it. I remember because someone asked, is pass like return? And no, it's not at all. Just be aware of that. Why care? Well, we showed a couple of cases. We showed maybe if we divide, well, it's important that our function still returns a value. It still returns a float, so we can have it return a float, but it'll be this not a number thing. It's a float, but it's not really, there's no number. There's no value associated with it other than it's not a number. Another one was keep asking, pardon me, assume it's getting input from the user and it calls divide, and if the user enters the wrong number or enters a denominator of 0, well, they just say, okay, try again. And this will keep asking until the user does it right. This one was, if something funny happens, stop immediately. Stop running your code. And then this one was saying, if you try to divide and you can't do it, whatever, it really doesn't matter, just ignore it. All four are reasonable things to do in certain situations. But the whole point of this is the programmer in 1991 has no idea what you, in 2023, want to do in the situation where you're trying to divide by 0. All they can do is let you know that someone tried to divide by 0, what do you want to do about it? And then you deal with it accordingly. Any questions about exceptions? Yeah. There's preset ones, and they actually have a hierarchy. chances are, there's probably not going to be an exception for your specific situation. This one, there happened to be one, a zero division error. Usually what you'll see, there's just a general purpose exception that can be raised at runtime when your code is running. That's called just a runtime exception. And it's pretty high up in the hierarchy. Cool. Any other questions about exceptions? That was a good question. Forgot to mention that. All right, so this is a big one. The last few topics weren't really, we were learning something new, but it was fairly tangential, for lack of a better term, to the core ideas of things that we cover in this class. Now we're back on track to learning something big, new, and a pretty big core principle. Your exam is going to be full of this stuff, objects. And I'm going to just I'm going to qualify that statement by also mentioning, you got to remember, whenever someone asks, oh, is the test accumulative? Meaning, will it cover things that we learned in week 1, week 2, week 3, even though we already had a test since then? Of course it is, because week 1 was variables. And I can't ask you about a loop if I don't assume you know what a variable is, right? So if I were to say something like the test is all about objects, there's going to be more than just objects on the tests. But if I say the test is all about objects, that obviously means up to and including everything you would need to know in order to do objects, right? We've progressed along the way. So I'm going to warn you. Well, first of all, you've been dealing with objects already. Strings are, they're objects, and lists are objects. But those were already written for you. Someone wrote the code to say to a computer, to say to Python, this is what a string is. Same with a list. Someone wrote the code. Lists don't just intrinsically exist inside your computer. No. Someone had to write the code to tell Python, this is a list, this is how it works, this is what it knows, etc. Someone wrote that, and that's great. The reality is, you could write your own things like a list. You could define your own class. A class is the definition of, what a list is. So a list has a class. Then you can make instances of that class, and that would be like an individual list. If I made 5 lists, I have 5 instances of the list class. We often call instances of classes, we call those objects. And remember that whole topic on references? Everything with objects is references now. Okay? It's going to be that way. Some programmers, a lot of new programmers might end up hating objects. They think, what's the point? I don't need an object to do what I want to do. And you're right. Just because you can do something with an object doesn't mean you need to. And just because you can do something with an object doesn't mean you couldn't do it another way, without objects. Of course. But objects are a nice way to compartmentalize and encapsulate, kind of group together important pieces of data together and or important functionality together. It's a way to group things together. And it's really good at facilitating abstraction. Abstraction being something like, I don't need to know how every little piece of my internal combustion engine works in order for me to get into the car and go, right? I interact with my car's engine at a very high level. Turn it on. That's it, right? There's a lot going on under the hood, but I interact at a very high level. And that's a very good abstract way. And we like that because it makes it easier to reason about things. If I've got an internal combustion engine that I know works, someone built it and I know it works, and I'm able to interact with it at a higher level of I turn it on, I turn it off, then I'm in great shape. right? It makes it a lot easier for me to work with engines if I can deal with it at that level. I've got like a frog in my throat today, holy moly. So, lists are a very special type of object called like a data structure or a collection. And collections are special in that they really have grouped together data and functionality. But that's kind of the point of a data structure, is it stores data and you've got some nice functionality for managing that data. But in general, objects are often a lot simpler. And in general, now there's no hard rule about this. Objects, you're allowed to make objects and then you can do whatever you want with the tools that Python gives you. But often programmers don't really love to combine data and functionality that much, because they are separate things. But we can combine some, as long as we're like careful about it. We can do as much of combining data and functionality as we want. Python gives us the tool to do that. But in terms of good design, we might need to ask ourselves if we should. But when we're talking about a list, there's a lot of data and functionality together because it's a data structure, and that's kind of the point of that class, the point of that object. So with a list, there's data that's obviously stored in the list, the data that we put into it, and there's a bunch of functionality we can do with a list, right? We can say append to a list. We can remove something from a list. And what do we call those functions, like those special functions we call on objects? What do we call those things? Methods, yeah. Really, it's just a function, but we call them methods because they act on an instance of a class. If I said mylist.append, it's a method, but that method has the implicit argument of the instance of the list that's there. Because like, what's it appending to? Well, the list you told it to append to. One thing neat about Python is Python makes it pretty obvious that there is an implicit argument for each thing, but we'll see that when we come. All right. We're going to make circle objects. But in order to make circle objects, we need to tell Python what a circle is. Let me show you what I mean. If I go over here and I say it's going to tell me what the hell's a circle, right? I'm trying to make a circle object, and this is the syntax I would use to make a circle object. But the problem is Python doesn't know what a circle is, so we have to tell it. And we tell it by defining a class. We get to tell Python what a circle is. And our circle, what data should a circle know? All a circle really needs is its radius. That's all we really need to know about a circle in order to know a lot about a circle. If I know its radius, I can get its like diameter, its circumference, its surface area, etc. So a circle, the data that we're going to associate with the circle is going to be its radius. And this is just an example. I think the best way to learn about objects and stuff is to learn by doing, and this is an example. It's a relatively simple one, but it's a great place to start. You'll notice it goes up to objects 4, so we're going to continue to build on the complexity. But I'm not really going to, I'm not going to hide anything from you here. I'm just going to go, and then the next time maybe we sprinkle a little bit more on there. So we need to start a class, and here's how we do it. We tell Python class, it's a keyword, so Python goes, instead of like def for a function, you say class to define a class. And the name of the class. This could be whatever you want. Of course, you want it to be a good name. And there is a big convention convention you have to follow. You don't have to follow. Python will do it even if you don't follow it. But I'm telling you, you have to follow. So here's a convention. Every variable we ever made, and even the function definitions, they were all snake case. All lowercase, underscores to separate words. The exception was constants, where it was all uppercase, but words were separated by underscores. With objects, with classes, you use camel case, and you always start it with an uppercase letter. Always, 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 always. So then if any programmer sees a piece of code where something starts with an uppercase letter, I know it's an object. So this is the convention that you got to follow. So I don't call it circle, I call it circle with an uppercase C. Now camel case is traditionally something like this. This is a circle. You don't use underscores to separate words. You just start the next word with an uppercase letter. But typically with camel case, you start with a lowercase for the first one. But if this was an object that I wanted to call this is a circle, you still start it with an uppercase. So it's camel case, but you start the first letter with an uppercase. That's the convention. Going back to circle just because it's nice. There. Now, interestingly enough, with just this code, I can actually, Python now goes, oh, there's something called a circle. It can't do anything, but there is a circle. In fact, I can now even do this. Yep. I made an instance of a circle class. I have a circle object here, referenced by the reference variable myCircle. And if you don't believe me, this is telling you, ignore the main bit, but it's telling you, well, this is a circle. It even knows. I can't do anything with this circle. I can ask it its type, and I can probably print it out, and it's not really going to say very much, anything interesting. It's going to say, well, it's a circle object at that memory address. Great. Not really that helpful, but I can make a circle. So the next thing that we usually, almost always, add is a constructor. Now, mind you, everything you want to be a part of the circle class has to be indented, right, under this bit. Then if I have a function in there, it's indented, but then everything inside that function needs to be indented. This isn't new. This would be the same if you had like an if and then a loop or something, right? You just got to keep indenting. But here we go. Now this is what we call the constructor or initializer. Technically it's not a constructor, but often people will just call this a constructor. This is a very special method. It is a method, listen up, because I get 100 questions about this later, and it's always kind of annoying. The constructor automatically gets called. You never directly call the constructor. You are never going to call this method directly. Never. This gets called when I make a new instance of a circle class. On line 1 of that second cell, it ran this method. All right? So I never call it directly. When I create an instance of the class, the constructor automatically runs. Now there's a couple of things in here to note. The first thing is, there exists a bunch of special methods in Python for objects. They're called magic methods, or sometimes people call them dunder methods. I hate that. But they're magic methods. And they start with 2 underscores, have a special name, and then end with 2 underscores. They're called dunder because it's double underscore. I don't know. So underscore, underscore, init, it's init. Careful, don't write int. The number of times I've accidentally typed this for my constructor and then spent way too long trying to find out what was wrong with my code, only to discover that I made that stupid mistake I always make again. Just be careful. It's init. So it has a special name. The constructor has to be called this. Underscore, underscore, init, underscore, underscore. It has to be. And you never call it directly. You indirectly call it by creating an instance of a circle. You will notice that this method, it looks just like a function, but this method takes one argument. But this is the implicit argument. This is the argument that you never actually pass to this function, to this method. This is self is a reference variable to the thing the method was called on. For the constructor, I'm going to warn you that this is an idea, this is a concept that throws a lot of programmers off at first, but it usually quickly, the blanks get filled in pretty quickly, because this is something hard to explain until you see the need for it and what it's doing. But it's usually, in my opinion, looking at it in the context of the constructor, it doesn't make a lot of sense, but once we write another method, it'll make a little bit more sense. But that first parameter there in the parameter list will always be the implicit argument, meaning I look at this method and I go, it has one parameter, but if I were to call this method, which I am effectively doing by doing this, I don't actually give it any arguments. Even though you're like, well, it needs one parameter. Well, not really. Self is a special variable. It's a reference variable that refers to itself. Let's see if I can hit this a little harder right now. You know what? Give me a moment and I'll come back to explaining self. Now here on line 11, I'm going to get rid of the doc strings just for brevity. You obviously write these. All this method does, all of this constructor does, the constructor is a method, but it's a special one, is it assigns this variable that I'm calling radius to be 0. But there's, of course, something special going on here. I'm saying self.radius. When I say self.radius, I'm saying, okay, self is a reference variable to a circle object. In fact, the current circle that this method is running on. When I say self.radius, I'm not making a variable that I assign the value 0. No. What I'm doing is I'm making an attribute, which is just a variable. But it's a variable that is connected to, it's tied to an instance of a circle. I think this will be best explained like this. Oh, I got to run this first. There. I've got my constructor. On line 1 of the second box, I say my circle, which is a reference variable. My circle is going to reference some new circle. And when that new circle is created, it gets this attribute, this radius value of 0 assigned to it. In this particular example, then I say, okay, on line 2, I'm saying my circle, the reference variable to that circle, tell me your radius. So it's just like a variable, but I need to go through the instance of the circle to get it. Let me show you this. If I were to say my now, when I print it out, I said, okay, I create a circle. On the next line, I go and I say, okay, my circle, your radius is now 99. And then when I ask the circle, what's your radius? It's 99. Here, On line 1, there's only one circle object is being created in this example code right here. And it actually has 2 reference variables to it. Can you tell me what one of the reference variables is? This isn't a trick question. Don't be shy. All right, you got the easy one. What else is a reference variable to a circle? Self. My circle.radius and self.radius, it's the same. Self and my circle are aliases to the same instance. Let me show you another. Okay, another. There. Does this code make sense? I made 2 circles. I said the circle referenced by my circle, your radius is 99. And when I'm doing that, like, when I'm dealing with the circle referenced by my circle, any self reference variable is going to reference the circle, my circle. But when I'm dealing with the circle that's referenced by another circle, self refers to that one. The 4 of you right there, 1, 2, 3, 4. You're all circle objects and you have a radius, right? I reference you by you are circle 1, circle 2, circle 3, circle 4. All right? So I have 4 reference variables to 4 separate circles. You know what? You 2 can be, I don't want to leave you 2 out. I got circle 4, 5, and 6. Okay? The 6 of you are circles. I have 6 reference variables to circles. Sorry, everybody else. All of you have a reference variable inside. Now, if I say circle 1, that's you. Okay? But you have a reference variable called self. And where does it point? No, point at yourself. It doesn't point back. It's a reference variable to you. So if I say circle 1, let's say your radius is 5. Okay? I say circle 1, what's your radius? You go, okay, self, what's my radius? And you go, oh, it's 5. If I say circle 3, that's you, your radius is 9. All right? When I say, hey, circle 3, that's a reference variable to you. You have to ask self, which is a reference variable to what? No, that's radius. Me, exactly. You say, okay, self, what's my radius? We have to access that attribute, that variable. We have to access that variable through a reference variable to that object. Even though you are the object, you need to reference, you need a reference variable to where it is, which just happens to be yourself. Sure, it's just like self-reference, but it's very important. So here, I have 2 circle objects, and they both have their own radius. If I were to make 1,000,000 circles, all circles have a radius in my code. But they might have different values. How many are in here today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 people in here right now. All of you have a first name, right? Raise your hand if you don't. That's what I thought. You all have a first name. But the value associated with that first name is going to be different, probably different. I mean, they don't have to be different. Just because both circles have a radius, if I have 2 circles, the fact that both have a radius, that's great, but they are not interconnected in any way. They are entirely independent. So circle A's radius and circle B's radius are 2 separate variables. They're 2 separate attributes. Any questions about any of that? Now, yeah. Now, the way I'm doing this here is kind of silly. I created a circle, and in that constructor, I tell the circle I need a reference variable, I need an attribute. Sorry, I need an attribute to keep track of the radius. That's all that code does. But what we could do is we could actually update the constructor to give it a little bit more power, where instead of assigning them here, I can assign, oops, I gotta run that first. I can assign, I can pass to, when I create the object, I can pass the argument of a radius to it, and then it goes and it sets the radius to the attribute radius. So I don't need to do it separately. So this is a little nice. But notice, when you look here, it looks like the constructor takes two parameters, like it has two parameters. But when I'm accessing that method, I only gave it one argument. What's going on? Well, the first one is the implicit one. I don't actually need to give it to it because it just knows self. Self is always there. Also, the fact that I called this radius and the attribute was called radius, it didn't matter. It could be called whatever. It's going to function as long as it was assigned to the attribute radius, and that's how I'm going to access it. Now I'm calling it radius because I think it's a good variable name here. And now if you're going to say, hold on, they both have radius. You have two variables with the same name. Isn't that going to cause an ambiguity issue? No. Because one's like a parameter, it's like a variable, and the other one is an attribute. It's a different thing. Now, if this was just a regular function, if I were to do this, well, yeah, that's a problem. That's kind of ridiculous. But also, look at this. Just to make it obvious, I run this, it's going to say there's no such thing as a radius. Because remember, variables have scope. That variable, QWE, and that variable radius, they only exist inside that method, the init method, the constructor. This worked the same way it did with functions back a month and a half ago. And it's worked the same way since. Variables, parameters that exist inside a function only exist inside that function. After the function's done, they're gone. The computer says, all right, I don't care about them anymore. If I want radius to be persistent and actually exist after the lifetime of the constructor being run, I need to assign it to be the object's attribute. And I do that by saying, okay, self.radius. So now it's a variable that's associated with an instance of a circle, and it needs to be remembered. All right, now we're back at it. Now, here's an example of what will happen. If I do like this, this is what I always, this is where I always get mad. Remember how I said I always make that same mistake and I spend way too long trying to figure it out? I'll see the error like, circle takes no arguments. I'm like, what? What are you talking about? I'm looking at it right here. The initializer takes, it needs a radius. And why is it telling me I can't do it? I spend way too long only to realize, oh yeah, it's because it's in init. Because it wasn't the constructor. I made int, which is entirely different. I need the constructor. So there you go. Any questions so far? Yeah.
What would be another example of an implicit thing? Like self makes sense because it was referencing.
It's always self. It's always going to be self, yeah. And as we do more, you'll see. Think of the list, for example, right? When I say sumList.append, and I give it a piece of data, the list is going to go, okay, where am I appending it? To myself. So it's always the self.
So you wouldn't be like referencing to.
Some other object, no. Now, I could throw in another argument that is a reference to another thing, but that wouldn't be the implicit one. It would be a reference to something else. And we will see an example of that in the next topic. Cool. All right, let's add a little bit more functionality. I'm going to add a diameter method, and I'm going to get rid of the docstring for brevity. Yeah. There. I added the method to the circle class called diameter. It has one parameter, self, but remember that's the implicit one. It returns a float, and all it does is it returns 2 times its radius. If this didn't say self, it wouldn't work. It would say, I don't know what radius is. It needs to be self, because I need the circle objects, the value, that attribute, radius that belongs to that instance of the circle, I need that. And multiply it by 2, and that gives me the diameter. So I can run this, and now I can say diameter. There. Let's get rid of another circle. We don't need it for now. Now, mind you, when I'm calling the method, I needed the parentheses, because it's like a function, right? You call a function, you use parentheses. When I was getting the radius, I didn't have parentheses, because radius wasn't a method. It was just an attribute. It was just a variable associated with an instance of the circle class. So just be mindful of that. So there we go, diameter. I'd like to point out, look, I wrote a diameter method. Sure, it's a simple one. It returns 2 times the attribute. But all I had to do was put this method inside of the circle class. And remember, all of your methods have to start the parameter list with self, that implicit argument. All I did was throw it in there, and now I can access that method by just saying reference diameter, 198. So let's take a moment and talk a little bit more about this implicit argument. This function, this method's first parameter is self. But I keep saying, well, it's the implicit one. Self, okay, look, I called diameter on the reference variable my circle. So it's my circle. That's a reference variable. It gets me to a circle, and the circle's over here. Let's say this is the circle, all right? So, my circle. I'm saying, my circle, tell me your diameter. All right? So, I go to the diameter method inside the circle class. I didn't give it any arguments here, but it got for free the implicit argument, which was whatever, a reference variable to that circle. So my arm, which is something that points to the circle, the reference variable, is given to this circle, so it knows where it is. So it's an alias. I didn't explicitly provide, I didn't say my circle.diameter, my circle, right? Because it's going to say, well, no, you gave it 2 arguments. And you're going to say, like, what, there's only 1 there. Well, no, you gave it 2 because the implicit one was there, which was the instance I'm calling it on. So my circle will become self. They're aliases. Are you happy or unhappy? I can't tell. Your faces are really blank. Some people are frowning. You're really frowning. I don't know if you're happy or unhappy. I can't tell. Two thumbs up. All right. Because no one, when you were explicitly asked if you're happy or unhappy, two people gave a thumbs up after 30 seconds. I'm going to assume they speak for everybody then. We can go and add a few more methods, but first, in order to do that, in order to do area and circumference, we're going to want to use pi. Pi is defined in the math library, so I'm just going to go add that there. And I'm just going to copy these two. Get rid of the doc strings for now. And there we go. Now I've added two more methods to my class, area and circumference. Area doesn't really get any more parameter other than the self one. And circumference doesn't get another, there's no need, none of these methods need an argument other than, the self. But area is pi r squared. All right, so we do pi times radius squared, and circumference is 2 pi r, 2 times pi times r, 2 times r times whatever, right? There we go. And having run this, well, now I have access to area. What is your area? Well, it's pretty big. Nope. Yeah, so I've added more functionality. Again, they have self, but that's the implicit argument. We don't actually give it the value for that. I could do this. Oops. Now if I call circumference, there, I changed circumference to take, have one more parameter. I gave it some string, and for whatever reason on line 15 in it, when I called it, I said, print out QWE. Why? Because I could. And now we can actually see, well, yeah, it did that. The computer ran this function, this method, printed something out, great. It had there was no purpose for it. And then we returned the circumference, great. They're just there's nothing really more magical to them than being functions that are assigned to a specific instance. And we've got these implicit arguments that are references to instances of a specific object. And as proof that the constructor is run, right? When I call this here on this line, it ran this line of code. Now, it's a pretty silly line of code, but I put it there just to show you that it, in fact, is running. Let's get rid of this one down here. Yeah. Now, if I wanted to test these classes, I would do something like this. I'll go down here after the object. Now, these attributes are, what's wrong here? Oh. There. I put the tests, the tests are not inside the class. That's important to note. They are just outside the class. See, they're not indented. And here we go. I'm running some assert tests. When I create a circle, its radius of 0 with a radius of 0, its radius better be 0. Its diameter better be 0, its area better be 0, and its circumference better be 0. Then if I make a circle with a radius 10, well, its radius better be 10, diameter better be 20, and these better be close enough to their area and circumference. But you'll notice that these assert tests, before our assert tests were fairly straightforward, right? You wrote a function, convert Celsius to Fahrenheit. All right, well, given this input, this should be the output. Given this input, that should be the output of all the functions. But you'll notice that here, there was a little bit of setup required in order for me to test any of these methods. I needed to actually make an instance of a circle. There was a little bit of setup code. We're actually starting to hit the limit of the effectiveness of our assert tests. As we start to do more complex things, as we start to make objects, and as each thing we want to do requires a little bit more setup, these assert tests become not a great way to test our code effectively. They'll work, don't get me wrong, they're great. But there are better ways to test code. Better isn't the right word. There's more systematic and well-defined popular ways to write tests like this for our code called unit testing. And that is not next topic or the following one, but the one after that. We're going to hit unit testing. These are definitely working here. They're doing a great job, these assert tests. But we are becoming, you'll notice, it required some setup, which wasn't necessarily a bad thing. This wasn't a lot of extra work. But the amount of setup required for things as we go might get bigger and bigger and bigger. So it's a little more difficult to use these assert tests effectively for testing our stuff. Any questions about these objects? No? All right, I'm going to assume everyone understood everything completely, so that's fantastic. All right, we'll wrap up here. No sense starting the next topic with 2 minutes to go. I'll see you all later.